So what I was telling that in this question I am clarifying this thing. So here it is a molybdenum complex. So two carbonyl group is present and one is CP, and here eta 4 type of ligand is there. Okay, so ME-Mg pair, if we do this thing, so this is delta positive charge and this is delta negative charge. So Me can act as a nucleophile. Okay, so what will happen that this Me will attack here and it will form this type of thing. So previously it was the planar type of thing, but after this it is become the sp3 carbon. This is sp2, but after the reaction it will be sp3. Okay, so that's why it's not in plane. Okay, it formed this type of this type of complex. Okay, and eventually what will happen, these three carbon will now participating in the as a ligand to the metal center. And if you calculate the electron count, so here also it is 18 electron and here is 18 electron. So that's why there is no positive charge here over here, but there was positive charge over there. Okay, so the answer will be B. Now let's go to the next question. So this is the next question. You have 2-3 minutes time to solve this question, and please try to answer me. And if you have any doubt, you feel free to ask me in the chat box. So it's always open, and try to solve this question because it will be helpful for you. চ্যাপ্টারের গ্যালি প্রুফ এসছে, মাঝখান থেকে কিছু রেফারেন্স ওরা বাদ দিয়ে দিয়েছে, চলে গেছে রেফারেন্স কেটে গেছে।
কিসের গ্যালি প্রুফ এসছে?
বুক চ্যাপ্টার।
ও সেরকম
Okay, I have got one answer. Other people? Okay. So yes, the answer is B. Still, mm, I uh, I have to clarify this thing. So if you draw the structure of this complex, so this is actually ruthenium complex. So this is L, and it's actually easy. If you uh, have seen the product, then also uh, you can understand what type of reaction is possible. You don't have to know the actual mechanism as well, but still I am showing you the mechanism of this reaction. So this hydrogen is there, chlorine is there, and here COR, right? So in the product you have what? CORH, CO, right? So CO has to come from here. Okay. So what will happen? So if it is that if you see that this is the alpha position and this is the beta position. So actually what is happening that this will react here, and this actually this bond CO will kick out from this place, and it will form RHCl R, this type of thing, right? So CO is in the alpha position. So alpha, the carbon monoxide is releasing from the complex. So that's why it is alpha migratory elimination, right? And now you see that with R, this CO Cl are the in the ortho position, and R and H is also in the ortho position. One thing is that it is in the axial position, and it is in the equatorial position. So what will happen now? The as a product they have given RH, right? So RH, how it will come? So if these two kick out from the is been kicked out from the complex, then only RH will form. And what is the reaction? Reaction is the reductive elimination, right? So if the reductive elimination is possible, then this RH is going out from the complex and it is forming like this. But you have to understand that here one vacant space or thing is also vacant position is also there. So another ligand will come and bind with this thing and will form Cl. So eventually it will form Al3RHCl. Okay. So this is this product, and this CO is coming from there, and this RH is coming from there. Okay. So everyone given the right answer. So the answer is B, migratory alpha migratory elimination followed by the reductive elimination. Okay. Let's go to the next question then. how to different these two terms, simple reduction and oxidative reduction. I mean, it is necessary that uh, did you mean that oxidative addition? I mean, oxidative reduction is quite unnatural, right? Whatever we talk about it with respect to the this metal center, okay. So if it is oxidative addition, that means the I mean two ligand is one molecule is actually breaking apart and two thing is going into the metal center, and because of this the oxidation state of the metal center is actually increasing, okay. And for the reductive elimination, the something is going out, and because of that the I mean the oxidation state of the metal center is actually decreasing by 2, okay. I mean if it is the n electron complex, then after the reductive elimination n minus 2 electron complex will be there, and if it is in oxidative addition thing, if it is a n electron complex, then it will be n plus 2 electron complex, okay. So because of that the oxidation state of the metal center is increasing, that's why it is oxidative oxidation. That is the I mean definition, one of the definition of the oxidation, right? So increase in the oxidation state is oxidation, and decrease in the oxidation state is reduction. So in this case, so what is happening, that metal center, the I mean the oxidation state of the metal center is increasing, that's why it is oxidative. And the other cases, similarly the opposite case is that the oxidation state of the metal center is decreasing, that's why it's reductive. And why it is oxidative addition, because some ligand is conjugating extra, some ligand is conjugating to the metal complex, that's why oxidative addition. And uh, from the metal complex, if something goes out, then it's elimination, right? Something is eliminating from the from this place, that's why it is reductive elimination, because the oxidation state of the metal center is also uh, is decreasing, that's why reductive elimination, okay. But in that case, whatever I told you in the previous case, you will see that the this type of alpha migratory elimination or beta migratory elimination, the oxidation state of the metal center does not change, okay. It remains the same. If it is a n electron complex, it will be n electron complex, okay. The if the sorry I mean if the oxidative oxygen state of a metal center is in, then it will remain the as a in, right? So this type of thing is happens, that's why that is a separate thing. So you can say differentiate in this way, okay. I think it's you have understood or not, I don't know. Please uh, clarify that it is you have understood or not. Okay. So any one of you have done this? Okay, let's start to solve this question. So what is happening, what is in this thing, that this is the compound, right? This is the organic compound that is given, sorry, this is the image. Now this is a carbene type of metal complex, right? So it can bind either in this center by 2+2 addition reaction or to this center, right? So different factors plays a crucial role here, right? So if you see this thing and if you compare these two things, so if you will find that the electron density of this center is much more because three alkyl group is there, but here the two hydrogen is there, so electron density of this center is much less, right? So and also if we found that there is methyl group is there and this bulky group is there, however here only hydrogen is there and methyl and there is another alkyl group is there, so statically it is much more favorable than this one. Anyway, whatever path you will take, you will get the similar answer, no, same answer, not a similar answer, actually the same answer. Okay, so first it will attack here. Okay, so what it will happen there, like this MO ln CH2 is there, this is a carbon complex, so it will form this type of bond. Okay, like there is MO ln and CH2 actually, so here, so it will form this type of transition state and eventually it will form this. Okay, and this is a 2+2 2+2 addition or 2+2 reaction, whatever you can tell, reaction 2+2 reaction. Okay, so after that what will happen, this bond will cleaved, so it is, you can call it as retro 2+2, just the opposite of this, because this bond is so strained, right? I mean, if you know this thing that three-member ring or four-member ring is very strained thing. Okay, okay, so it will break apart. Okay, so if it breaks apart, and what will happen, it will form this, right? And here there will be it will go out, right? It will. Now these and these two also can do 2+2 reaction, so similar reaction will happen, 2+2. Okay, this type of thing will occur, and eventually this bond will break, that is the retro 2+2, and it will form okay. So here other type of thing is also possible, that other type of byproduct is also possible, but it will be the more favorable one. That's why I have shown this mechanism. Uh, Anyone can tell that it is breaking like this, it can break like that also, right? If it breaks like that, then it will go back to the reactant, right? So there is no point. So it has to be break like that way, so to get the actual product. So keep it in mind that other thing is also possible, but this is the most favorable one. So that's why I am showing this thing. So the option will be option A. So check whether if you have any problem with this thing or not, if everyone have understood this thing or not. Okay, then going to the next question. So okay, I've got one answer. Other people also try to answer. Okay, so yes, C is the right answer. Why? Why? Already Jaya told that why C is the right answer. So basically, it is a less statically hindered, that whichever will less statically hindered will have a higher tendency to bind with the metal center, because it is also favorable, right? So if you follow this thing, then there is least statically hindered, there is no substitution is there, and there is hydrogen group is there, so this is much more favorable. And after that, this one, one methyl group is there, but compared to this thing, here two methyl group is there, so only one methyl group is there, that's why it's much more favorable than this one, and this is the least one. Okay, so if there is another, here also the substitute is there, then it will be much less compared to this thing. Okay, the reaction rate will be very less. Okay, so always try, uh, keep this logic clear. Okay, it will be very easy for you then. Don't need to memorize all these things, but keep the logic clear, then it will be very easy to deal with this question, because these are very easy questions. Okay, so as everything is clear, then we are going to the next one. So this is the next question for you. You take some time to solve this thing, because it's a bit tricky one, so you take time, uh, 2 3 minutes or 5 minutes you take. হ্যালো, হ্যাঁ আপনি খুঁজে পেয়েছেন? আচ্ছা আচ্ছা, ঠিক আছে, এসছেন তো? আচ্ছা ঠিক আছে, ঠিক আছে, ঠিক আছে, থ্যাংক ইউ। Okay, n- uh, now it is audible. I'm sorry for that. Okay, many of you have given the answer, so let's start to solve this thing. Okay, so then I will tell you which one is right or which one is wrong. So okay, so so this is a zirconium complex. So first, when you will add NBOLI, okay. So NBOLI is actually a very strong base also. Okay. So what will happen that this zirconium will substitute this lithium LiCl will go out, and all this chlorine will be substituted with N-butyl group. Okay. And there is Cp and there is Cp. So what is this? Two equivalent of NBOLI you need, and how much will come out? That two equivalent of LiCl will come out. Okay. and after that what can happen, right? So first thing you have got this LICL is the thing which is getting out from the reaction mixture, and after that what they have told that they have used this thing, right? And also what is happening actually it this type of uh, I mean, what I will say, this compounds is actually can go for the beta hydride elimination reaction, right? So, if it is a alpha, this is beta, so it can form beta. I mean, this is also alpha, this is also beta, right? So, these two protons are present, okay, that can go for the alpha beta hydride elimination. There is so much possibilities are there, okay. And also what other thing can be possible, that these two groups are ortho to each other, right? So it can do what, it can go to the it can go do the oxidative addition, reductive elimination reaction, right? So if it do reductive elimination reaction, so these two n-butyl and n-butyl group will go out, and this will form, and this is actually right. So it can go out, and in that place it can conjugate, okay. So after that what will happen, it can make a more specific type of bond to the metal center, like can form like this type of thing. It is actually not formed because already can form actually. So this will form, and eventually this force center will do the reaction and will form the desired product that was given here. Okay, so this is your this product, and what will x and y? X and y will be this one and this one. So if more specific, two equivalent of this thing and one equivalent of this thing, because this is the product of reductive elimination reaction. So the only thing is that it can two of this n-butyl group will conjugate and do the reductive elimination reaction, and will be go out from this ligand in the from this metal complex. So have you understood this thing? If yes, then we can go to the next question. This is a bit tricky one, but it's okay. I mean, all this from there you can actually what you will see that from this type of question you have to predict something from the, because every all possibilities are there, but there will be some hint in the either in product or in the options, okay. So from there you can choose the path where in which way it is actually doing the reaction, okay. So okay, so let's go to the next question. You have to tell the which statement is wrong, okay. So you solve it, and after 2 minutes I will discuss after 2 minutes I will discuss what is the this question. Okay. ফোন করলে পাওয়া যায় না কেন? তো কতবার ফোন করলাম বল, দুবার। আমাকে তখন লোকটা ফোন করেছিল যে ইয়ের জন্য, ওর নাম কি জানো, ও প্রথমে জায়গাটা খুঁজে পাচ্ছিল না বলে। তারপরে আমি ওকে বললাম, বলে দিলাম, তারপরে তোকে ওখানে আসিস না। তারপরে এবার এসছি কিনা বুঝতে পারছি না, কোশ্চেন করে আমি তোকে ফোন করলাম, ফোন তুই ধরছিস না, মেসেজ করলে মেসেজে রিপ্লাই করছিস না।
আমি এই ঘরে দেখছিলাম না,
ফোনটা রাখিস না কেন তোর কাছে?
ওইখানে ফোনটা রেখে দিয়েছিলাম। তুই তো বললি ও আসবে, আমি তো জানি না যে চেনে না, আমি কি করে জানবো?
চিনি না, ওটা অন্য লোক।
রাখা হয় না, নিজেই ভুলে যাই।
এটা ভুলে যেতে, আমি এবার তুই ভাব এরকম সিচুয়েশনে আমি নিচে যাবো না ওপরে যাবো?
ঠিক আছে, হয়ে গেছে, চলে এসছে, বলতে না।
আমি শেষ পর্যন্ত তোকে ফোন পাচ্ছি না বলে ওকে ফোন করে দিয়ে জানলাম। কি মিলেছে না মেলেনি?
হ্যাঁ মিলেছে, কিন্তু মাথার উপরে এখানে একটা হালকা স্পট আছে, এইটা হচ্ছে এখানে একটা হালকা, এটা পিওরটা যেটা, তো এখানে একটা হালকা স্পট আছে, ঠিক আছে, মানে পিওরই আছে, একটু হালকা আছে। তো এইখানে একটা ভালো ইন্টেন্স স্পট এসছে, এইখানে হালকা হালকা আবঝা আবঝা আছে, এখানটাতে একটা হালকা আবঝা আছে, আর এইখানটাতে মানে আমি স্পটিং দুবার করেছিলাম। তো এবার এটা ইমপিউরিটি না, এটা থাকে না, এটা জানি না।
এক কাজ কর, ব্রোমান্সের উপর ডেট করতে পারিস? টাকা আমি করবো,
ইয়ে করে করতে হবে তো সিরিজ দিয়ে।
অনেক কিছু ব্যাপার আছে,
রোটাটার হয়েছে, রোটাটার বাদ ঠিক হয়ে গেছে, ওইটা এই রুমটায় লাগিয়ে দেখলাম, ওই রুমটা একটু সাগরদার চলছে, ওটাও ঠিক হয়ে গেছে, চিলারটাও ঠিক করে দিয়েছে, আর ওই ইয়েটা দিয়ে গেছে, ডেলিভারির যে ফর্মটা আমি ওই যেখানটায় ওই NMR এর ইয়েগুলো থাকে ওখানে রেখেছি। ঠিক আছে, ফর্মটা নিয়ে আমার মনে থাকে না, অ্যাকচুয়ালি যে পকেটগুলো জায়গা বলে আমার নাম।
Okay, sorry for this interruption in this lecture. So I have got one answer, actually two answer I have got. So okay, so let's be clear about this thing. I mean, in between A and C there was actually a confusion. So and it was also some of my fault also, that A will be the actually a wrong statement, so answer will be A. Okay, so why not C? I am telling, if it is a D0 complex, then always it will go alpha abstraction. Okay, so it's not a wrong statement, it's a right statement. Okay, so actually in the previous case I'm going back to the previous one. So if I go back to the previous one, there is a intermediate step also, okay, where CO is binding like that way, and after that this CO is going out and forming this thing. Okay, so if you do the alpha elimination or alpha beta elimination reaction, so then always if it is a D0 complex, then there is a chance that the oxidation state, there is not a chance that the oxidation state of the metal will increase, right? That means when it is I am talking about the oxidation state of the metal center will increase, that means the electron in the outer shell of the metal will go out, right? If it is a D0 complex, then there is no chance that in the outer shell there is no electron of the metal, right? So it cannot go to the higher oxidation state, because it is the highest oxidation state of that metal, right? So in that case, what it can do, that the alpha abstraction reaction, where the oxidation state of that metal center will not increase, it will remain same. That I told about the when I discussed about the what is the beta elimination or alpha elimination reaction in the previous case. Okay, so but if it is not a D0 state, D0 complex, then always the alpha elimination will be more preferred than the alpha abstraction. Okay, so uh, the option A is the wrong idea, wrong concept, wrong statement, and option B, it is a metastasis reaction involve four center cyclic transition state. Yes, it is a four in this type of reaction. Actually, I mean the transition state is four, like it is a, if it is a metastasis reaction, like if you take this type of reaction. So if it is a sigma bond metastasis reaction, then it will form like a transition state where this bond is breaking, and this bond is forming, and this bond is breaking, and this bond is forming. Okay, so this type of transition state is there. So it is a four membered, four centered transition state. And after that you will get your compound, that is AX, and like that type of metastasis reaction it can happen. And in the last thing, the attack by external nucleophile is facilitated by the pi acceptor auxiliary ligand. Yes, it is true, because when the nucleophile will attack to the metal center, the pi acceptor will can accommodate those electron density because of the back bonding. Okay, so it can actually accommodate the electron pair and can stable the metal center. So it's always true that the attack by the external nucleophile is facilitated by pi acceptor auxiliary ligand. So here only option A is incorrect, and so it will be the wrong statement will be option A. So it's okay. Okay, let's go to the next one. This is an easy one. Please try to answer this thing. Okay, what to answer? Okay. Okay. Yes. Actually, D is the right answer. So I am explaining why it is. It's already written there. Anyway, so if we follow this thing, so it is what is it is actually this that ln pt sorry pt. Yeah. So if it goes beta hydride elimination reaction, so then first what will happen that this type of thing will it will rotate like that, and there will be an interaction between this bond. Okay, so eventually what will happen that uh, this is also a transition state. Okay, this bond is breaking and this bond is forming, right? And eventually not actually this thing, this is also breaking. Okay, instead of this will form. So what will happen that this type of thing will form, right? This is only can form because this type of four membered type of transition state can form in this case. Okay, but in this case if you see that this rotation of this chain is very restricted in this case. So if it need to form the four centered thing, so it has to form like this way. So it's a very strained condition because of because of that ring. So this reaction will be much more I should say much more slower compared to this, because the free rotation of this long alkyl chain is always it can be done, but in the ring case it is not always possible, right? There is so many strain is there. So that's why the beta elimination reaction will be much faster in this complex 1 compared to complex 2. Why? Because this type of beta hydrate can come closer to metal bond. That's why the this reaction is much faster. Okay, so this is the alpha and this is the beta, so this is the beta hydrogen. Okay. uh, okay, then going to the next question. Okay, got one answer. Hmm. Let's say we will discuss. Okay, so one answer is A, one answer is B, and other one. Okay, C or D conclusion. Okay. Okay, let's start to solve this question. So this is the complex, right? So if you take the oxidation state of the Ti is +4, okay, and Ti is uh, 3d2 4s2, okay, so only 4 electron is there. So here Ti 4, Ti plus 4, that means it is actually a D0 complex. No vacant, no valence electron is present in case of Ti, right? Now when you will give the heat, so this is the alpha, this is the beta, right? Right. So you can say that the okay, what will happen, that there is two chance, right? One is beta hydrate abstraction and one is beta hydrate elimination. Okay, so in case of beta hydrate abstraction, what can be done, what is possible, like the your compound the your beta, in case of beta abstraction, two things is possible: beta abstraction, beta elimination. So beta abstraction, what will happen, that other ligand, that is other auxiliary ligand, will take the beta hydrogen and will go out. Okay, and in case of beta elimination reaction, what will happen, that that is actually, I should write in this way, otherwise you will understand in better way. Okay. Right. So if we do the beta elimination reaction, let's say it is going to the beta elimination reaction. Okay. So what will happen? This type of benzene intermediate will form. This hydrogen will be there, and there is Cp, and there is Cp. Right. Now if you do the calculation, the oxidation state of this so after that, what can happen, that the reductive elimination can happen, like these two can, sorry, it has to be in this position to do the reductive elimination, because unless or until it is in the cis position, it cannot do the reductive elimination reaction. So this type of thing is possible, right? So this thing in this pathway, okay, in this pathway this can form. But you see, this is a +4 state, right? And it is in the +4, 5, 6, 7 state. Okay, so here in the valence electron only 4 electron is there, so it is the highest possible oxidation state of the titanium, right? So it cannot go to the +7 oxidation state. Okay, so it cannot go to the +7 oxidation state. Okay, that's why this type of beta elimination reaction is not possible, is not feasible for this type of complex. Rather, what it will do beta abstraction. So beta abstraction means this ligand will act as a base. Okay, so this will attack here, and it will let's take this one. Okay, this will attack here, and this will go there, and there will be a formation of that bond. Okay, so eventually what will happen? Cp2 TI, this thing will present. Now if you count it, it is +4 only. Okay, so this is the product is same, okay, but the path is different. Okay, so here it is happening through the beta abstraction reaction. Okay, not through the beta elimination reaction. Okay, uh, have you got the do you have any confusion? Is it okay? And as a byproduct, what is forming? Benzene is forming, because if it does the beta abstraction reaction, this phenyl group is actually taking out this proton, and then the formation of benzene is happening here. Okay, then go to the going to the next question. Okay, we have 10 question over here, so this is the next question. Okay, after finishing this thing, I will tell you something. I mean, I have in one question, I actually didn't miss. I explained the mechanism not correctly, so I will correct it. But before that, we will finish all these questions, and after that we will correct all these things. ABP. Okay. Okay, let's see. A. Okay. A. Okay. Yes, actually, the right answer is A, not B, because I know you have already maybe you have wanted to tell A, but you see that there is the phenyl group is there, so it cannot be the answer. Okay, so what is happening? I am telling you what is happening. So CP2 TICL, right? So if you write down the structure like uh, CP Cl2, sorry, Cl, so it is also plus 4 state. Okay, so whenever you will give the magnesium and PME3 in two equivalent, what it will do, it will replace this PMA3 will be this chlorine will be replaced by this PM3. Okay, so it will form this thing, and what will come out? MgCl2, right? And it will act now, it will act as a acting ligand, acting catalyst, okay, for this reaction. So after that, what will happen, this 2-PME3 will go out. Now it is also plus 4 state. Okay, no, it is plus 2 state. Okay, so it's plus 2 state. That PME3 doesn't is not a anionic ligand, so it is in plus 2 state. Okay, so it can bind to other complex, right? So what it can do, it can first it can do this. So now it is plus 4 state. Okay, so one can go out and can form this CP and basically both, fast at a time one will go out and it will form like this type of thing. Okay, and after that this group will approach and it will kick out this thing. This is also plus 4 state. Okay, but it will do simultaneously, it will go out and it will react with this thing. Okay, this center and this center. Okay, so what will happen actually, similar type of thing that I told in before. So that will happen, that this pH will be there and there will be pH and it will be Cp and it will be Cp. Okay, so option A will be the right answer. So here what is coming, what is forming, this is, if you write down the formula, Cp2 Ti PME3 2. This is the option A. This is the A. So this thing, and B will be the your this product. Okay. Okay, let's go to the previous question. One of that question that I yeah, this one I told you that see, this is also zirconium plus 4 state, right? Here it is also plus 4 state. Okay, so there is no way that two of them will equally will participate. I mean, will conjugate with this thing. Then it will be plus 6 state, but zirconium has highest thing is the plus 4, highest oxygen state. Okay, so what it will do, it will form this type of thing will not actually bind with the metal complex. Okay, so it will be there, I mean some interaction will be there with that with this thing, and it will here, or like if you follow this thing there, this thing will be there, and eventually it will form this type of complex where it is also plus 4 state. Okay, so it cannot go beyond the plus 4. Okay, I mean higher to the plus 4, because it is in the highest oxygen state. That I wrongly told you that it is actually binding to the metal center, but it doesn't happen. Okay, you understood this thing? If yes, then we can move to the last question. Okay, and sorry for this thing. I mean, I wrongly told you, explained you this thing. So this was the 9. So this is the last question we have for this evening, and we again will meet in the next coming Friday. Actually, this class supposed to be in the previous Friday, but it postponed to Monday today because I had some other work. I went to PMRF symposium, so I couldn't take that class. So that's why I am taking now. And this week we also have our last class for this course, and after that you will have the exam and all these things, but last class in this week on Friday from 6 to 8. We will try to be there if possible, and read all these things and try to solve all these things. It will not be a very difficult one, but these topics are very crucial. Okay, so if you go for NEET or GATE, this question comes, okay, either in section B or section C, it will come. Some of the organometallic reaction or this thing will come, and also if possible that try to follow some book as well. So what type of thing you should do, that is not covered here, that the metal bond, how many metal bond is present in the complex, and all this 18 Newton rule and carbene, these type of questions come. Okay. That carbene, two types of carbenes are there, like Fischer carbene, Schrock carbene. Those are there. I mean, if you take any organometallic book, you will get what is the difference of those things. You will get it. Okay, and it's very crucial thing to learn this organometallic things, because if you don't have interest also, this type of question will come. in the network gate, then it will be very easy question. If you keep your logic clear, then you will be able to answer all these things. Okay, I have got one answer already. So other two, Ashish and Vini. It's a very easy one. I mean, you should answer it. Okay. Okay. No, actually, it is not the case. So here, what will happen? Is actually right. So unstable complex is option T, because here you can see the beta hydride elimination is possible. Okay, but here it is not possible. Okay, I mean here it is not possible because of the ring strain. Okay, and here it is also not possible because it is actually will form C triple, I mean 4 bonded with C. It doesn't have any meaning. Okay, and here also no beta hydrogen is present. But what can happen that the it can form reductive elimination type of thing, right? But reductive elimination only happens when the ligand is too much crowded. Okay, then only the it is more feasible to for a complex to go to the reductive elimination reaction. But you see in this A or B, it's not that much crowded. Okay, I mean not that much steric hindrance is there, so there is no driving force that is actually pushing the complex to do the reductive elimination reaction, right? But in the other case, I mean it can go the do the reductive beta hydride elimination reaction, uh, right? So there is no problem in that thing. Okay, so it's a very stable thing and it can happen, right? And if you uh, mm, uh, see the oxidation state of the platinum, so in each of this case this is actually a platinum plus 2 state, right? So it can go to the higher oxidation state, right? So plus 2 is not its highest oxidation state, so it can go to the higher oxidation state as well. That's why it is what is happening is that the reductive elimination or all these things is not actually it can go to the beta hydride elimination reaction. Okay, so is it clear to you? Or do you have any counter justification of your answer? Okay, then for today it's a end. So bye, study hard, and we will meet in the coming Friday again at 6. Okay. So okay, I am Soumya. So I'm a Bengali. So I I am showing my name. That will be easier for you to remember. So this is my name. So I am a PMRF fellow at IISER Kolkata. So I am a third year PhD student, and actually this is not my field. I work on polymer chemistry under the supervision of Professor Shide. So that is this is actually a this is not my field. Okay, so, so this is my intro. Okay, then good night for. Okay, you are also from polymer background. Okay, great then. So still you have to have this knowledge how to contact me. You can have my mail address. So I am giving you my mail address. If you have any problem, you can reach me. So this is my mail address. Okay, then bye. Good night. So stopping the presentation and